Recording started. Welcome everybody to Enclave Users Group. Today we're talking about issues and quirks of R in the Enclave, and Saad's going to give us an update on some cool environment happenings.
Sure, thanks, Sean. And I will try to make it short so to give you some time and Jared to go through concrete examples. Most of what I wanted to talk about are the profiles, the Spark profiles that you can use in Code Workbook as well as in code repositories. Some updates that we did to them, as well as some tips to troubleshoot either solve issues or to understand how much compute you have when you're using these profiles. Before sharing my screen, I just wanted to get a sense. I see a lot of familiar faces, but some new people. Caxton, Kanchan, Yankee. I just wanted to know how familiar you are with the Enclave and Code Workbook. Have you used this before, maybe by show of hands?
I haven't started yet. I was just being introduced to it like last week.
Okay. I can be very brief in like giving an overview and then talk specifically about the profiles. So let me share my screen. Let's see. So I think, can you see the homepage?
Yes.
Okay, great. So I will start from this folder, which everyone has access to. It's in the N3C training area, Enclave Users Group. So if you want to save resources from what we talk about today, you can find them here. And so the first thing I will do here is create a code workbook. And so for new people, very quickly and on a high level, code workbook is a notebook inside of the N3C Enclave, where you can import data sets that are in the Enclave and then do analysis on them, code-based analysis. So you can use SQL, R, and Python. Let's give it a name. Example workbook EUG. And so generally, when you start from a workbook, generally the first thing you do is to import your input data sets that you're going to work on. So in this case, just for the sake of example, I'm going to import some notional data sets. So say the condition table and the person table, which are in the OML format. And so quick navigation here on the left-hand side, you have, so every data set that you either import or generate is represented as a node that you can look at here visually on a graph, and then you can see the list of all your nodes in here. So when things start being complex and you have many data sets and nodes, you can look and sort here to find your way. From each data set, you can either create a code transformation. And so you have these three languages, R, SQL, and Python. And we'll talk about templates and visualizations another time. So you can, every transformation is a function that takes one data set or multiple data sets as inputs. So here we have the person table and we have condition occurrence. And then these are typically functions that takes these data sets, they're represented as data frames. And then you can do transformations, and ultimately what you return, the return type of the function has to be a data frame or a null if you don't want to return a data frame. When you run your code, the results will be, if it's a data frame, it will be seen on the preview tab and you can open it on a separate tab. If you have visualizations that you produce, they can be seen here. You can C logs and print statements here, and this is where you write your logic. You can also use the console on the right-hand side, which just helps you execute one-off statements, not necessarily in scripts if you want to test your code or do some quick data exploration. And it's also available in the 3 languages. And once you start having multiple transformations, you can factor your code by putting functions and imports in this global code section that will help you like have. So that is kind of almost like the brief overview of Code Workbook. Every Code Workbook has an environment or a profile. So an environment is essentially 2 things. And if you go here, we have the profile that we're using by default is called this default R3.5. And so if you click on the configure environment, just to get more information about what's included in this profile, a profile is basically a collection of packages that are available in your Code Workbook. So in this case, you have all these packages, Python, scikit-learn. These are the ones available for this default R3.5. So for example, if you want to use NumPy, the only thing you need to do here is do like import NumPy in your transformation, and then you'll be able to use NumPy. Why? Because it's already included in the environment. Similarly, if you have let's see what our packages are included here. Let's say match it, you just do library match it, and then you'll be able to use this match it package if you're using R. And so you're able to do that because the packages are included in your environment. Now, not every package is included in this environment. There's just a select number of them. For the default ones, these are the ones that are more commonly used. If a package doesn't exist in your code environment, if you want to be able to use it, you have to add it to this environment and have the profile resolved. And so, for example, here, say I want to use TensorFlow and it's not included here. All I have to do is click on Customize Profile and then look for TensorFlow in here and then add it to my environment. And the reason I'm able to find TensorFlow, this is able to find most of the open source packages that are in the major Conda channels. And I'll get back to that in a bit. So you customize your profile, you add the package you need, and then you hit update. And this will trigger what we call a solve of the environment. So what now this is trying to do is just figure out the right versions of all the packages included here that work together, that don't have dependency conflicts. And so if I go back to, actually, let me go back to the default one for a second. Let's pick this one, which is compatible with R4, which is the latest version of R supported in the platform. One thing you can do to when you configure or pick an environment, a profile, on the right-hand side here, you can see that for some of the packages, I'm explicitly asking that I use R4, or here in this case, matplotlib 2.x. And for all the others, what automatic means is what it means is that I'm letting the solver, Conda solver, figure out the right versions for this environment to resolve. And so sometimes it's the latest, sometimes it's not the latest, but it's the latest one that works with all the others. And so maybe let me pick one that solves quickly. So once the environment solves, if you click on View Resolve Packages, you can see the actual versions that are being used in this environment. So Python, we're using this one. NumPy, we're using 1.9. So if you're wondering what versions of the packages are the ones that are in your code workbook, you can look in this. This is like the versions that are being used after the solve completes. The other thing that you can look at in the profiles, I talked about the combination of packages, and I'll talk in a bit about troubleshooting when the solve takes a while or when you have some errors and the environment doesn't solve. But before that, I wanted to talk a little bit about compute. So Foundry, or the N3C enclave, the platform, is running on top of Spark. Spark is the computing environment or framework that is being used in the platform. It's being used for scalability reasons. It's basically a parallel computing and storage framework that allows you to work a little more efficiently with large data sets. As you probably noticed in the platform, for new people here, we have some very large data sets. Measurements is billions of rows. The conditions data set is also huge. In order to be able to work with these packages efficiently, the platform uses Spark to run the computations in parallel and store the data sets in parallel. And so if you want to know what are the resources, like how much compute you have in your profile, there's this Spark settings section that you click on. So it's telling me for my default profile, these are the kind of compute resources that are available. And the most, I guess, useful ones to understand, or important ones, are the driver. So in Spark, you have a driver that orchestrates your compute, and then you have executors that run in parallel to execute your computations. And so for the driver here, you have one core, you have 6 gigs of memory, and then you have 2 cores for each executor that you claim, and each core having 6 gigs. These are the main ones, and I'm not sure how much I should talk about for Spark. Like, I have maybe a visual that will help here very quickly, because I don't want to take too much time.
Can I ask you a question on where you just were? Or is that something, can you change those settings, or they're fixed?
Say that again.
Can we change those settings, the driver cores and the memory and all of that, or is that something that's fixed?
It is fixed by profile. We have a number of predefined profiles that have bigger compute resources or driver resources, and I was planning to talk about that. And more recently, we've created this profile high driver cores and profile high executor cores and memory. And so these ones have higher resources if you need them. The other thing that we can do is we can create new profiles for you on a need basis. And when we create them, we can select some of these settings here. So you cannot select them on or change them on your own, but depending on your use case, we can create a profile that is tailored for your use case. But part of what I wanted to show today is these 2 new profiles that hopefully should be good enough for you if you have, especially if you're using R and R data frames and you're running things in memory and not using Spark. This profile high driver cores and memory is going to be very useful for you because it has a larger driver and a more performant driver. It's kind of a better version of what used to be profile high memory, this one. So if you run computations in parallel, especially for the early filterings of large data sets, and you run SQL or PySpark, then you should be using, especially if you needed, this one's the high executor cores and memory, because this one claims more executors and more performance executors. Does that answer your question, Kim?
Yes, thank you.
And briefly, for people who are new, I wanted to just show this visual because it might help. So I talked about Spark as being the compute framework for the platform. Basically, the way it works is if you run a function, or what we call a transformation in the platform, that takes one or multiple data sets and then runs some code to do filtering or other transformations, the way it generally works is that this computation is split and distributed across a cluster. And it like, basically you have multiple executors doing bits of that computation to take advantage of the parallel processing. And so similarly for the storage, when you have a data set or a table in the platform, the way you see it is in terms of rows and columns, but in reality, the way it's saved in the platform is in what we call multiple partitions, mostly Parquet files, and that helps to optimize the storage, but also to optimize reading from these data sets and executing computations on them. So like you can have multiple data sets, in this case, in this visual, saved into 3 partitions. And so that's a good visual to have in mind when you think about Spark. I don't want to go into the details here, but just know that there are some operations that are faster and more efficient than others. Filtering is quick and efficient when the partitioning is done well. When you're doing joins, it might be computationally intensive because it requires what we call a reshuffling, which is basically putting all the partitions together, doing the join, and then similarly, the group by is similar. So like the joins, group bys, distinct partition bys, these are more expensive operations. So that's all I wanted to say about Spark. And the reason I'm mentioning that is because I started talking about the driver and the executors. When you're using your code, when you're running code in Code Workbook and you're using pandas or R data frames, you are collecting the data sets that are saved in multiple partitions into all of the data sets into the driver. And so when the data sets are too big and the driver is not big enough, you might start having some memory issues, which is why it's good to understand when to use Spark and when to collect into the driver to just use your regular R data frames or pandas to run computations in the drivers. And one thing that is useful to know here, and probably most of you on the call knows that, is that you can, if you want to use pandas, you can make sure that the inputs is in a pandas format or a Spark format if you want to use Spark syntax. So I talked about profiles a little bit, about the packages. You can check the Spark settings of your profiles here. Let me talk quickly about the solving and the good practices, like troubleshooting the solve errors. And then I'll stop there because just to give time to Sean and Jared to talk about the other topics. So everything is documented in this. There's a Palantir documentation. So for a code workbook, you can, if you click on help, you can go to the documentation from here, and it takes you to the code workbook documentation. And one of the things I wanted to talk about today is what I touched based on today is the environments. So that just like is an introduction on what is an environment, how to select one, how to customize one, what a profile means. And this is just some background information on what happens in the background when you select a profile and it initializes. On a high level, there are 2 steps. There is a solve step, which basically takes the list of the packages that you specified in your profile and tries to figure out the versions that work with each other. And there is the install step, which is basically retrieving these packages from where they live to have them in your environment. And it's good to understand these to understand why sometimes it takes time for your environment to initialize. And it could be for various reasons on each one of these steps. Once you understand that, there's some good ways to troubleshoot. So there are 2 things that could happen when you select a profile or you customize a profile. Either it takes a long time to initialize and it's frustrating, or it actually fails to initialize. And then you have some errors, and sometimes the error message is helpful and sometimes it's very hard to understand. Quite often when the environment fails, it's because the packages that you want, they have some dependency issues, and like they're incompatible in some way. And so a good way to troubleshoot is, so like you can undo what the packages that you revert the change that you just added, and you try to simplify your package. So start with simplify your profile. So start with a small profile, and then start adding the packages to your profile to understand or figure out which package is causing the dependency issues. The other thing that you can do, and that can make your packages initialize fast, is say you have a profile that works. You can look at all these versions here. So like, for example, pandas is 0.25.3. What you can do is also you go back to your profile, and then you specifically pin pandas to that version that was already solved. That will save the solver some time, because it won't spend time figuring out that this version works. And then it can focus on the newer packages that you're adding. So that's one way to speed the initialization up, is to specifically pin the packages to the versions that you know work. So I'll stop from here. I'll stop here for the good practices on the initialization issues. The last thing I wanted to mention is like a good way to perform your analysis. Generally speaking, and some of you already know for people who have been working on the platform, your starting point is generally the data sets that are in the data catalog. So if I open the data catalog, by the way, feel free to stop me if you have questions or if this is unclear. But generally speaking, you have access to LDS data or the identified data. I won't open the data sets here. And these are massive data sets. Some of them are million rows, but this is generally your starting point, because you want to do some filtering based on a list of codes that you have to build your cohort. And then once you build your cohort, you go on to do your analysis, whether it's producing visualizations or descriptive statistics tables or doing some machine learning models. And so that second step is where generally you want to use the languages and syntax that you're more comfortable with. So for example, using pandas or using R data frames, which only you work on the driver and they're not leveraging on Spark. And so a good way to think about this is the early filtering step, where you start from these very large tables and you want to get down to the cohorts that you need and only the data set that you need for your analysis. For this one, I suggest that you do two things. On one hand, you can use the profile high executor course and memory. This one leverages on Spark, and this one is a very powerful to do computations in parallel. So you use that in conjunction with using either SQL or PySpark or Spark R, because that code is using Spark and it's making sure that it's distributing your computations for more efficiency. And generally, these steps just involve filtering, maybe some column dropping and renaming, maybe some joins. So these are easier to learn as a syntax and don't require a lot of Spark syntax knowledge. And then once you do that, and then you get down to the smaller data set that you need for your analysis, then you can switch to the profile high driver course and memory to just do computations on the driver using R data frames or using pandas. So maybe I'll stop here because I don't want to take too much time, and maybe another time I'll go through concrete examples. But I just wanted to mention the principles here and some of the good practices. So I'm curious if you have any questions or if any of this is clear or unclear.
You said you'd switch the environment.
Yes.
I'm kind of nervous about having the same workbook sometimes use one environment, some the other. Would
Yeah.
you split the nodes into different so that you wouldn't have to be just flipping?
I think so. I think a good way, and yeah, that's a good point, Will. You can do both, but I think a good way to organize your work is you have a workbook, which is your, call it cohorting or filtering. That one uses the the profile, which is high executors, cores, and memory. And then once you have the output data sets, then you create another workbook. And that's maybe your analysis workbook that uses the high driver. It's a good way to also think of it and organize your work. And this way you won't have to be switching profiles back and forth on the same workbook. So that is a good point.
So Saad,
I like that approach.
this is
Go ahead.
this is associated with that. At one point, I think you mentioned that there's some optimal number of nodes you should have in a code workbook. Like beyond 90, it's actually impacting the speed with which you can run your whole workbook. So you should only what's the number, of nodes you should have in a code workbook?
That's a good question, Kim. I don't have an exact number in mind. I know my rule of thumb is that if it starts being more than 40 nodes, 50 even, not only it might affect the UI performance, but also organization wise, you might get lost. I mean, obviously there is the contents panel, which lets you jump between nodes and not look for them in the graph. But organization wise, it might become too much above 50. I don't know if we've done an analysis to like have an exact number of when a certain number of nodes starts degrading the performance. But I think, yeah, up to 50 should be fine unless you had a different experience. But then it's also good to keep it not too big just for your organization purposes.
Well, just like you said, I think it is helpful to have one workbook that's, the filtering of the big tables, and then you could use multiple. One is for, your smaller cohort, and then one is for your modeling or something like that.
Yeah.
But that's good for new users to know, because I think my first code workbook had so many nodes in it, and you helped me solve a problem, and you're like, whoa, what is this? Too many nodes in it.
Yeah, and it might be helpful in the future because for some of you who like to work with other tools like Jupyter Notebook or RStudio, we are in the process of deploying them inside the platform. So there's pros and cons to that. But one advantage is for people who are used to these tools, they can use the tools that they prefer. One of the maybe there are two disadvantages, but for the purposes of this topic, performance-wise, if you use RStudio, you're not going to be using Spark. And so you can think in the future, once you have these tools, you still have a workbook or a code repository, which does your filtering and cohorting using Spark. And then whatever data sets you have as outputs, you can import in we call them code workspaces once we have them, RStudio. So you can either use code workbook if you prefer, or you can do it in RStudio or Jupyter for your analysis purposes. So this will be helpful also once we have these tools in the platform. Does that make sense?
That's great.
The one disadvantage for now for having RStudio or Jupyter in the platform is that you don't have you lose a little bit of like the provenance features that you have in Foundry. So here in Foundry, if you use a code workbook or a code repository, you know exactly what are the inputs. You can walk back to the analysis. It's hard to tell sometimes on an RStudio have that like provenance tree as well as in Foundry, but maybe in the future this will also improve. Yeah, but any other questions?
Yeah, I just had one. Is there documentation on selecting the profile for a code repository, or do all code repositories use the same profile?
That's a good question. No, you can actually select profiles in code repositories. And there is documentation for that. I can look for it and if I can find it now quickly. But in code repositories, if you go to settings,
Okay,
let's see, Spark, you can, so depending on the permissions, you'll be able to add some of these profiles. But in order to, and you can actually, the good thing about code repositories, if you can actually have, you can have the profile by transformation, like each script could be using a different profile. All you need to do is add a specific, I don't know why I opened this one in particular, but it's about adding a line here that says, I want to use this profile. And it's a line of code that starts with add configure, and then you give the profile name. But there is documentation for that, and I can maybe send that as a follow-up just to save some time.
yeah, sure. If you just send a link, that'd be great. I'll look it up because I guess I never thought about what profile I'm operating with in a code repo. So maybe that's something I should pay more attention to.
Yeah, I mean, you have a default one, but depending on what you do, it might be good to use different ones. So I'll show you how to select them.
Thank you.
Any other questions? Okay, sorry, Sean and Jared, if I took too long, but over to you.
No, that was great. Thank you.
That's great stuff.
I'm very helpful. Thank you.
Yeah, so I think, so now for something completely different. I think I confused people when I was out hunting for people to present. I think maybe I got Saad in at the same time as Will and Jared. As I was going to talk about profiles, and Will and Jared are going to talk about R. So maybe what we'll do is, if we can't get through all the R stuff, we'll just take one of the topics and do it another week. My little R trip is really quite short, so I'm gonna do that one. So one thing to know, oops. Hope if I showed the right thing. So one thing to know about R is the data, as many of us know, maybe not all of us know, live in this Apache Spark land. And Apache Spark has its own types of data. And there's a date type, and there's also like a long type, and R doesn't have a long type. And so when you have an R transform and you're reading the input in as an R data.
Does everyone know what a long type is? It's a 64-bit integer as opposed to 32.
Thank you. I actually was like, oh, do I know what a long type is? When you read it in and you're saying convert it, you're saying read it in as an R data frame, you could leave it in its original Spark format, but then you have to use the Spark R library to work with it. Or you can say read it in as an R data frame. And what it does is it converts it from Spark into an R data frame on the fly when you run this transform. But there are a couple of types that cause issues when doing this. And I've illustrated the two of them that I've run into here. In particular, longs when they're being read in, and I actually had trouble reproducing this example. In this example, they're being read in as a numeric vector, but sometimes they'll be read in as an integer 64 type. And so when you're working with R, this str function is really handy because it'll show you like what the types of your columns are. And so if you read in a long column from your input and it turns into an integer 64 right here, because a long is a 64-bit integer, R does have an integer 64 type. It's rarely used. And I found that tidyverse packages don't like to work very well with integer 64 types. So what I'll often do is if I'm going to work with a data like that, I'll just convert it back to an integer with as.integer. Then I have a 32-bit integer, and R can work with it just fine. So that's one sort of tip, is to take your long columns, and when you read them into R, convert them to integer with as.integer. Or the other way to get around that is to actually use, do whatever you need to do to make it an integer instead of a long upstream. The other issue that we've noticed, and this is actually I think a recently surfaced bug, I don't know how long it's been around, but if you have a column that is a date column and it's almost all nulls, this only shows up in some cases and it's actually kind of random. If you have a date column and it's almost all nulls and you try and return it from R, it will give you an error. And the signature of that error, if you scroll down far enough, is invalid type N. I can only guess as to why this particular bug happens, but I think it has to do with the fact that there's not an automated, the way that they convert dates from R dates into Spark dates somehow uses a sampling strategy. And if the sampling gets only nulls or NAs, then you get this N, and it's like, I don't know what to do with N. I don't know what kind of data to turn it into. Nevertheless, the way that we've discovered, the best way that we've discovered so far to get around this is to convert that column with the as.posicct type. And what that does is it converts the date into a timestamp. And the conversion for timestamps from R into timestamps to Spark works fine. So by converting my date into a timestamp, when I look at the str of it, now I have a posicct, which is R-ish for timestamp, and an integer column, which is an integer column. And then when I return it, it comes out as a timestamp rather than a date, but I don't get that error. And I have my integer there. So that's a nice thing. And according to the support people who helped me figure out this particular workaround, PySpark is just likes to work with timestamps more than dates. Most people who are working with date times in PySpark use timestamps. If you need to get your data back to a date, I think timestamps and date columns interact just fine in PySpark, but if you need to get it back to a regular date, you can use SQL for that. And so you could say, you know, I want to select a date conversion of my timestamp column to get it back to a date. And if you ever want to take something and turn it back into a long, you can use cast whatever column you want as long to get it back to there. So those are just a couple of oddities around R types that can cause issues and some workarounds around them.
So Sean, are you saying that what appears to be a bug with the handling of dates, that's a bug that's never going to go, well, for our purposes, will never go away? In other words, it's not something that we can anticipate to see fixed.
I haven't pinned the support team down on that particular question. It's a bug. I mean, it's pretty clearly a bug. And so I hope that they'll someday get to it, but I don't know how difficult of a bug it is. And so, you know.
Okay, but can you use, I mean, aren't there a lot of functions that are designed to work with dates? Do they all work with timestamps equally well?
I gather so. And in fact, I gather that there's a number of functions that will only work with timestamps, but not dates in PySpark anyway,
Okay.
SQL.
I see. Okay.
I think I would cast it to a date as soon as you can. Like
Yeah.
use date time just for the storage in Spark, but once you get back to R, cast it to a date. And so then when the bug goes away, the rest of your code doesn't have to change except for that one line that puts it into a date column and reads it. It puts it into a date time and then casts it back to a date.
Okay, thank you.
I just wanted to say, yeah, this is one of the issues that comes up quite frequently, especially when I attend office hours and people come to this issue. I wonder if, Sean, it's possible to have just a small community note that describe it, or and I can also help with that, just to refer people to it, because it's so common that, yeah.
Yeah, that is a good idea.
Usually when people have these kind of issues, and I immediately spot it because I've seen it regularly, and they're like, oh, how do you know that? Like, this has been literally the same issue for everyone. Yeah.
Will or Jared, will either of you be able to fit your thing in 15 minutes, or should we punt?
I think I can do the RDS part, Jared, or I can wait.
I can try to make it through mine. Let me.
Okay.
Yeah. So yeah, building on what was said by both of you, I have some synthetic data, and this is in the Enclave users group. So I have a large data set that's built on the synthetic data that mirrors the logic liaison work that Andrea and others have built. So I fed the SynPuff data into there. So it's got a lot of data to play around with. Data means almost nothing, but you can at least fiddle with it. So to kind of demonstrate the difficulty with reading in big data sets into R, I just made a bigger version of this. And the frustrating thing when you're just starting is trying to figure out why I can analyze this in SQL and Python, but when I try to look at it in R, it just queues up and never runs and then sends out an error. It's for the reasons that were previously described. So the workarounds are either A, to pre-filter the data to just the stuff you want to look at in your transform, and then that reads in almost immediately. The timestamp on that is, fewer than a second when you filter down to the columns of interest, whereas when you leave them all in, it breaks. Or you can leverage Spark R. So Spark R, as Saad said, is retaining that Spark syntax. I don't use it for anything else. I only use it to gather data. So, but the syntax is here in this this space. If you want to use that, you have to gather the Spark R data set and then convert it into an R object. So then you can use it with R. So even when you're working with this huge data set, this process only takes, a few seconds. So it will gather those 4 columns of interest from a very, very large data set and then functions from there without issue. Whereas if you don't do that, you will stare at the screen for a few minutes and then it'll break. The other thing that I wanted to share, and I do have a little README at the top if you go in here that kind of just points to the Palantir documentation for this. The other thing was that I wanted to show you some examples of how you can modify plot output in R. The first thing is I just wanted to show you, this was something that took 6 or 7 months for me to figure out, but you can return, both a plot and a data frame. So you can do that within a single transform. And this is what it looks like. You'll get your plot in one, and then you can return a data frame in the same. And you can still use the log if you want to. And then finally, I wanted to just show some ways that you can manipulate plot output similarly to how you would in RStudio. So I made synthetic zip codes and gave everybody a synthetic longitude so that I could map it out and made this plot. And that's nice. Let's say that I want to look at a side-by-side plot of this, where one side is female, one side is male. So I can do that. And if we look at the code for that, it's just, normal grid arrange to arrange those. But because I don't have control over the size of it, it kind of gets squished, which is irritating. And there's a very specific syntax that you have to use in the platform to modify these, and it's different than you're used to in RStudio. So just finding that syntax, it's not complicated, but it is somewhat hard to find in the documentation, so be aware of that. And then you can modify the plot output. And so instead of having everything be squished, you can get it kind of play around until it's exactly the way you want it.
Jared, does
So-
that work with regular GG objects as well, or do you have to do a grid arrange first?
No, I did grid arrange so that I could make it look weird first.
Okay.
Yeah, so I
Basically any
so that's a
graphics.
squish it, but yeah, you can do that with anything. And you don't, I'm pretty sure you can modify a PNG as well if you want, but this is also the syntax to change your image. If you want to change your image output, I don't know where Palantir came up with this. Maybe Saad, you have thoughts, but this is the specific syntax you have to put before a plot if you want to change the output type. So with this, when you look at it, it makes the image a vector instead. So that's how that works if you do that. And so even when you add this to a report to be downloaded, that's the way you can change the image output is you have to put this commented field here. And I don't know where they came up with that, but that's the way you do it.
So it's purposely commented out like that?
It's just a commented, like this is just a pointer within the platform that says this is the image output format I want.
Huh.
Yeah. And that will change it. And then it persists. So when you add that to a report that gets reviewed, it persists. And in that report, you can extract it out and it's still an SVG in this example. So that's just like one of those nuanced, weird little things that you have to play around to figure it out.
Does that work for like PDF and
I don't think so. I've never tried to. You might be able to write it to like the R file path, like somewhere if you have the permissions, but I don't think most people can.
Back out.
Yeah.
My mind is blown there. That is awesome.
Yeah. So then why this is nice. Let's look at this plot. I could keep fiddling with this to try to get this space to go away. But since it's a vector, I can just wipe it out in post-processing in 10 seconds or remove the background color, whatever. That's why I like vectors, but yeah, it's just helpful because it's much higher resolution then.
That's really, really cool, Jared. Thank you.
Yeah. And that was all I had. So I'm glad that Saad covered kind of the foundation for this because it segued nicely.
Can someone put the link to that training space in the chat so that everyone can copy it?
Yeah, and feel free to use those synthetic data sets if you want to just fiddle around with anything. I don't think you can hurt anything.
And we'll post the recording here and the example workbooks in the Enclave users group section of the training portal as well, so people can find them there later. Will, would you like to talk about anything in the final few minutes that we have, or should we set up an advanced R data passing tricks session?
Let me squeeze in parts that go along with what Saad said. I think, well, okay. So like we were talking about, have two workbooks, at least one that manipulates or prepares the data, and then one that does the analysis. And this is also in the folder that Jared set up. And this is his synthetic data. And, I just threw in a little extra thing. So a lot of times in analysis, you don't want to use this, like you want to use condensed, collapsed versions so you can estimate things more. In this version 2, I've just collapsed it to a very few rows. Let's say it's a small data set, so you can't estimate all the interactions well. So just a few levels of this. And in the past, I would have saved this as a Spark data frame, and then all the analysis files would read a Spark data frame and then convert it back to R. Well, not convert it to R for the first, but they all have to do it exactly the same for the graphs and the analyses to work out. And one of the things that's lost is the levels, is the factors, and especially the order of the levels. One thing that's worked out, and you sent me down this road a month ago, is in this case, I'm reading a Spark data frame and using Spark R to collect it. That's not that can be the other way. It's these two lines that I'm advocating everyone do. Either in the node or here, somehow put it into the R style you want. In this case, I'm calling this a factor and this a factor. And then this R data pretty much comes from the documentation. I tweaked it a little bit, but it will save an RDS. So an RDS is a serialized data object. And so not only is it small, it retains the metadata. So you don't lose the date. But unlike a CSV, you don't lose like the date, it's knows as a date. And also you keep the factor levels. And what's really nice is, so now I'm in an analysis workbook. I'm pointing to that RDS that we just saved. And it's kind of weird, we're used to saving as Spark data sets. This doesn't save any data set, it just saves a file kind of associated with this node. This is pointing to that same node, just referencing just import data set, just like you always do. And these downstream analyses, make sure it says that it's a transform object. And then you use this other function that's pretty much from the documentation that converts it from an RDS to a data frame. Pretty much that line does it. And then the big benefit of this is now all the workbooks all the transform in this workbook starts off with the exact same data set. And all the workbooks you do in addition, so analysis 2, analysis 3, analysis 4, you don't have to keep updating code like this if you decide to change. Like you just decide on the data set you want for the analysis and you save it, and then everything else keeps it there. And the part that I wanted to squeeze in to coincide with what Saad said, the manipulation one can be almost any data set. Like if you're all doing it, if you're doing everything in, the environment can be almost any environment. If you're just doing standard SQL, I've never really had unless I did something done with the join, the performance has always been really good. And then the analysis, you can use one of the ones that Saad was advocating, like these guys, this one. And it's really nice because that can be a specialized one that's just for R. You don't have to have Spark stuff, and you're concentrating all your resources into one node in the analysis one, and then in the manipulation one, you're a more balanced Spark. So those are the basics.
Thanks, Will. That's huge. That's really, really huge. I'm going to do this with all my work from now on. The fact, so for the newer users, when you create a data frame and then you go to use it on a model, or you go to use it and create a table in GT Summary or something like that, you lose your factoring every time. For every node you use, you have to add that code to the top of your script every single time. So here you don't have to. Now you won't have to do that.
If you look at this one, it uses the same approach that Jared was talking about, where you're saving a data set. In this case, I'm saving model output, like from a generalized linear model, and then graphs from whatever.
So this strategy is pretty cool because, well, it's cool and it has one downside. The one downside is when you're doing it this way, the system, as far as I'm aware, can't partition it into multiple partitions as to what Saad was talking about. So you lose sort of the ability to do distributed computing on that thing. But what you're doing is you're sort of taking the R data frame or whatever it is, packaging it up into a file, and then sending that file along. And then downstream in R, you can then unpackage it. And so you don't have to worry about any type conversion issues like I was talking about, because it's all packaged up as an R saved file. And then when R unpackages it, it just says, oh, this is R created it. Now R is opening it and reading it. It's also a lot faster because it doesn't have to do those conversions back and forth between Spark and R. It's just sort of jumping about, and that saves the speed a lot.
So this is a non-example analysis. I mean, that's a lot of conversions you're doing over and over again, and it's a lot faster for just an RDS.
The other cool thing about that is that's how you would, if you need to send a model or some other fancy R type from one transform to another, you can use the same trick. So it doesn't have to be a data frame anymore to pass things between. You can take your linear model, save it, and then in the downstream, take your linear model and unpack it.
And we do that a lot with propensity, because the thing saved for propensity is not a nice rectangle, it's a nested list. And so you just do it once and then all the downstream can use it. Yeah. And a hint for some future thing, this we're using RDS. I think I've got close to having a good way to save it as Parquet files. So you don't have to be limited to R using it downstream. It can also do Python, but you still have all the factor levels. But before I recommend that, people have got to figure out some of the environment dependencies aren't quite right sometimes. Sometimes it works, sometimes it doesn't. Yeah. Right, I'm done.
Well, we're at time. Any final questions before we stop the recording?
Saad, Sean, what do you mean about the training portal has a Spark R module that links out to a great tutorial on the web? Where is that?
If you open the training portal, in the search, put Spark R, it should pull it up.
Okay.